building on what we learned with prime factorization and greatest common factor, we're moving into least common multiple. And so if you remember, a factor, I'm just going to go with F, are two numbers that when you multiply them together, they equal another. So that could be something like 2 times 3 equals 6. We would say that 2 and 3 are factors of 6. In contrast, a multiple is if you are basically skip counting by a number. So my iPad is, of course, scribbled there, but that would be with our example of 6. Maybe if we skip counted by 6, 6, 12, 18, 24. Another way you could think of that is if you think the first multiple of 6 is 6 times 1. The second multiple is 6 times 2. And you could use this as a shortcut for even the 10th multiple of 6 is 60. So today we're going to be looking at the common multiples of two numbers. And so for this video, we will be using the numbers 8 and 18. So our number set is 8 and 18. So one of the first things that you might want to do for 8 and 18 is just list out the multiples of the number and then we'll first find the first 3 multiples, common multiples of these numbers. So we have 8, we have 18, and I'm just going to list them out. When I count by 8s, I know it's 8, 16, 24, 8 times 4 is 32, 8 times 5 is 40, 8 times 6 is 48, 8 times 7 is 56, 8 times 8 is 64, 8 times 9 is 72, and then 8 times 10 is 80. So we'll just stop here, and we can always add on to that list if we need to later. So now 18, this is going to be not quite as straightforward, but I always have the side here that I can keep track of these. So we have 18, 18 plus 18 is 36, 36 plus 18 is 54, 54 plus 18 is 72, 72 plus 18 is 90. So I'm going to pause here for a moment and see how we're doing. So now I have these two lists of multiples. Let's quick highlight any that they have in common. So the first one that I notice is 72 and 72. And so we would definitely need to keep going from here, but as you can see, it's just a simple repetitive process of writing out all the multiples and then trying to identify the ones that are in both groups. So I'm not going to continue with this because I think you get the idea there. So really the heart of this video is all about finding the least common multiple. So when we were finding the greatest common factor, we were looking for the biggest factor that two numbers shared. Our least common multiple is going to be the smallest multiple that a number set has in common. And so when we have our list from up above, and so that can be a good place for us to start. And so there's actually 3 good strategies here, or strategies or methods. And the first one that you may have guessed is going to be coming up with a list of them. So you know what? In fact, I'm just going to copy this here and put this down below. So there it is. You could have done a list to find out the least common multiple. And sometimes, depending on what your number set is, this could be a pretty quick strategy or it could get really long. We were in luck because it was relatively straightforward here, but it's good to look at other strategies that might be more efficient with different number sets. So the next strategy that we're going to look at is using prime factorization, or our factor trees, or in class, that's not how you spell trees, or we may have called this our factor forest. And so when we're doing this prime factorization, you're doing the factor trees and then looking for what factors they all have. So when we do our factor tree for 8, we're going to start out and we're going to be pulling out all of our prime factors. So we know that we want to try to start out with 2, 3, or 5 when possible. So I know 8 is even, so it can be divided by 2, 2 and 4, and then 4 can be divided by 2 and 2. So 8, all right, keep track over here. 8 equals 2 times 2 times 2. Now let's repeat that process with 18. Again, it's even, so we know that 2 and 9 are factors, and 9 has the factors of 3 and 3. So 18 equals 2, and now this is where it's going to be a little bit different. I'm going to try to organize my factors in a way that all of the same numbers are kind of together. So since in 18, there's only 1, 2 as a factor, and then we move on to 3s, I'm just going to kind of stretch this out over to here. So when we're using these factor trees and prime factorization to find our least common multiple, you want to include everybody in the party, as Ms. Shervanian would say. And so we know that these 2's are together. This 2 came by himself. This 2 came by herself. And then these 2 3's, they also came by themselves as well. And so if we multiply those together, 2 times 2 times 2 is 8, and 3 times 3 is 9, and so 8 times 9 is 72. So our least common multiple is 72 if we use this prime factorization. So notice we didn't have to include every single factor, but we did want one from each matching column. Almost like they filtered down. So, get rid of some of those extra highlights. Oops. Nope, come back. That'll be fine. So we did end up with 72 like we did when we listed them out. So as you know, prime factorization, we also have another strategy, which is using the ladder. So if we do prime factorization with a double ladder, because we're only doing 2 numbers, you would set it up 8 with a bit of a space and then 18. And this is going to end up being pretty similar to those factor trees. We know that 2 is a factor of both of these, and so we're left with 4 and 9. So we don't have any other prime factors that we can pull out of there, and so we are just left with those 3 factors. So 2 times 4 times 9, 2 times 4 is 8, 8 times 9 is 72. There you go. Here is our least common multiple, 72. Now, sometimes you might need to find the least common multiple of 3 different numbers, and the triple ladder can sometimes work for that depending on the number set that you have, but the factor tree will always work for that. So let's quick do a triple factor tree. So if we're finding the least common multiple of, let's say, I'm going to make up some numbers off the top of my head. This could go horribly wrong. Let's say 28. Let's say we have those 3 numbers. So we could do a list of all of the multiples of those numbers, but that's going to get really long. So let's try doing the factor tree or factor forest, prime factorization for these 3 numbers. So 8, we know from up above, is 2 and 4, 2 and 2. So we have prime, prime, prime. 12 is a 2 and a 6, 2 and a 3, all prime. And then we're here with 28, which is 2 and 14, 2 and 7, and those, sorry about that accidental scroll. Those are all prime factors. So let's line them up. We know 8 equals 2 times 2 times 2. 12 equals 2 times 2. And now we have a 3, so I'm going to actually scoot over here into this area. So I've grouped all the 2's, and now I'm grouping that 3. And then we have 28 equals 2 times 2. Now, it's not even times 3, so I'm going to scooch even further to the right over here. So if you kind of look at this, we have one section for all of the 2's. We have another section for all of the 3's. And then we have another section for all of the 7's. So these 2's filter down, and we have a 2 times 2 times 2, times 3, times 7. So this should give us our least common multiple. Let's see. 2 times 2 times 2 is 8. 8 times 3 is 24. And 24 times 7. Well, I know 20 times 7 is 140. And 4 times 7 is 28. So 24 times 7 is 168. So our least common multiple should be 168. Now, this is a new strategy for me, so I'm not feeling super confident. So I'm going to use one of our other strategies to check and see. And I'm just going to do the list out the factors, or list out the multiples, rather. So from up above, we know 8, 16, 24, 32, 40, 48, 54, 60. Wait a minute. I'm sorry. That's wrong. 56. I feel like I screwed up here. I was trying to speed through it. Did I make a mistake? No, we're good. We're good. 64. Holy smokes. Undo. 64, 72, 80, 88. Oh my, you can see how this is starting to become problematic, especially with small numbers like 8. 88 is going to be 96, 104, 112, 120. Oh my goodness. I am running out of space. I guess I'm just going to go underneath that. 128, 136, 144, 152, 160, 168. So I'm going to stop there because if we did everything right, we should only need to go that high. So our next number was 12. So I know 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, oh my, 156, 168. All right, that looks good so far. There's nothing else. I mean, we do have here, we have 24 and 24 if we're looking for the least common multiple of 8 and 12. But I feel like 28 is probably going to not let us use that one because guess what? 28 is already greater than 24. So, sorry about that, 24. You are not our least common multiple. So, 28, 56. Didn't we make a list of this already? Nope, we did 18. Darn. Okay, so 56 plus 28 is going to be 84. Okie dokie. And then 84 plus 28 is 112 plus 28, 140 plus 28. All right, so it does look like 168 is our first or our least common multiple. Now, I don't know about you, but when I look at these two options, we have our factor tree where then we grouped the factors and then filtered them down. Or we had a big list like this. It feels like I have a lot more opportunities to do a small calculation mistake if I'm doing the list. So you can use whichever strategy you feel most comfortable with, but I would push you, when you have 3 numbers that you're trying to find the least common multiple, I would shoot for the factor tree because that's going to be the most efficient with the fewest opportunities for mistakes.